and what this algorithm is used for and how does it work. So let us understand selection sort algorithm. Selection sort is a sorting algorithm, is specifically an in-place comparison sort. So we do not move the element, but we just compare wherever they are just by checking the pointer, moving the pointer, and without moving the element, we compare, and when there is some comparison result, then we change it. We don't change just adjacent one. So it is a in-place comparison sort. Just remember this difference, in-place comparison sort. This is also a comparison sort. Bubble sort is also a comparison sort, but it is an in-place comparison sort, and bubble sort is swapping comparison sort. It has order of n square time complexity, similar like bubble sort, but it has an advantage that since it is in place, since this whole thing is an in-place comparison sort, it is better from those systems which has a auxiliary memory limitation, because it takes less memory than bubble sort. So selection sort for the same input will take less memory than bubble sort. So that's why selection sort is better than bubble sort. Now let us understand that what is the algorithm of selection sort. So the way it works is that first find the minimum value in the list, okay, then swap it with the value in first position, okay, and then repeat the steps above for the remainder of the list. That is important. You don't do the same operation on the same array. Now in the beginning your array size is this much, okay, this is your array. Later your array size becomes this. So first, when you have to find out, you first find out which one is the smallest, and we found this one. What we will do with this one? Swap it with the first one. So this guys gets swapped with this guy. So 3 comes here, 15 comes here. Okay. Now once this place is taken care of, what you do is that change the array itself. So now your array is this much, and you do find out what is the smallest in this array. In this array, smallest is 5. So what you do is that compare this with 6. If compare this with this, and then 5 comes here and 6 goes here. So now this 5 comes here, 6 comes here. Now new array for your selection sort is this one. In this one, find out the smallest one. 6, compare this with this. Now in case you have an array in which the first element itself is a smallest element, then you don't have to do anything, just go and work on the next array, and that is this size array. But in our cases, the first elements are not smallest one, so we have to do the swapping. So we swap 10 with 6, so 6 comes here, 10 comes here. Now the new array on which this algorithm you will use is 10, 15 and 8. Now here find out the smallest. Smallest is 8, and then this one you will swap with the 10. So 8 comes here and 10 goes here, like this. Next, again your sorting array will be this much. 15 and 10 is your array to sort. Out of this you have to find which one is the smallest. 10 is the smallest, so you will swap 10 and 15. 10 comes here and 15 remains here. Now an array with a single element is always a sorted array. So there is nothing to sort, and then finally you have sorted the array. Okay. So this is the algorithm for selection sort. And this is what it says. Effectively, the list is divided into two parts: the sub list of items already sorted and the sub list of items remaining to be sorted. So there are two parts: sub list of items already sorted, sub list of items remaining to be sorted. So from remaining to be sorted, you put one into sub list of items already sorted. So in the beginning, we assume that there is nothing sorted, so we replace one and go from there. Okay. The runtime analysis for selection sort is again order of n square, as we said, but it is better on in terms of the memory because it is in place comparison sort. What we will do is that we'll we'll see that how the selection sort works, like here. So the first thing is that find out the smallest among all of these. Okay, the first thing we will do is that find the smallest value from all of this. So let us do the selection sort and we'll find which is the smallest. Now it has found 2 and it is checking if anything smaller than 2 is there in this array. So it will keep searching if there is anything smaller than 2. Okay, it is searching if there is anything smaller than 2 because it has to find the smallest element, and so far it has found 2 as the smallest, so it will check. No, so it found that 2 is the smallest, so it swapped with the first place and 57 came here. Now it is finding the smallest among these. So now it will try to find the smallest among these. Okay. So smallest among these it has found is 21 and it is checking is there anything smaller than 21. It has found 3. Now it will swap 3 with here, and then in the remaining array again it will find what is the smallest one, and that is the way it will keep finding the smallest one and replace with the 57. So let us find. It has found 4. It has found this element as the smallest one, and it is going to replace which one? 57, this one. Okay, so just watch that what it will do. It replace 4 with 57. Now it is finding another smallest element in the remaining one out of this whole one, and then it will replace 78. Swap with 78. It has found 6 and it is waiting. So this is called selection sort because we are selecting the smallest element. We are not doing a adjacent swapping. We are selecting in the whole array the smallest one, 6. There is nothing else. So it will swap 6 with 78. Just watch what it does. 6 is swapped with 78. Okay. So that is the way the sorting algorithm, selection sort algorithm works. So if I make this animation goes little faster. So by using the selection sort, we have sorted the list of elements in an array. Okay.